Hey, Stats Chapter 12 Notes, Part 2. We're doing page 2 and page 3 of these notes. So we should be on the page that starts with the 4 principles of experimental design. So 4 principles of experimental design, these things are things that we want to make sure we have when we're designing our experiment. So the first thing is control. Now, with control, we're looking at controlling things, controlling as many variables as we can in order to minimize effects. So controlling as many variables as possible in order to minimize, we can say, undesired or unintended effects. So an example with this would be like if we're looking to see whether sleeping at 8 p.m. or whether sleeping at 10 p.m. is better for you, does it matter? And let's say we kind of made some sort of experiment. Ideally, we'd want to control as many things as possible. So like obviously we would control what time they fall asleep, since that's what we're looking at. But also another thing to control would probably be something like caffeine. Like we'd want to make sure that maybe all the participants are having normal amounts of caffeine. None of them are having way more caffeine than usual or something like that. So that's what we mean when we say control as many variables. Another thing to add here is we want a control group. Now, maybe some of you guys have heard that term before from your other classes. Control group is usually the group that's used to measure. It's like your baseline measurement. They either receive zero treatment or receive like the most minimal treatment. All right, so we want to control things. Next thing we want is randomization. And using this allows us to make valid conclusions. Oops. So once we have our, let's say, 50 experimental units, and we're going to make an experiment, and I have 2 groups of 25, it's important that you make sure that you randomize which participant goes to what group. So randomization, it'll allow us to make valid conclusions. All right, so we want to control things. We want to make sure things are random. This other one, replicate. Replicate literally means just kind of like do it again. All right, so what this means, a couple different ways we could do this is we can assign treatments to many experimental units. To many subjects. And another way to replicate would be to maybe complete the experiment again. But with a different population. All right, so kind of going to that example that I had where I said 25 people in each group, right? 50 people total. I'm looking to see, is it better to sleep at 8 p.m. or 10 p.m.? We have a lot of replication, right? We have 50 people. That's a lot of subjects, right? Obviously, if I want to make the experiment better, I could extend that number. Instead of making it 50, maybe I make it 100. That'd probably be a better experiment. That would maybe give us more valid conclusions. Let's say I finish that experiment, and then maybe I go do that experiment with a completely different population. Maybe now I actually just look at college students, or maybe I go look at high school teenagers. All right, so that's what replication means. So we want to control things, randomize things, replication, and then this last one, not always necessary. So you can put here, not necessary. But it's something called blocking. And think of this as like grouping individuals together. So it's similar to stratified sampling. If you guys remember in stratified sampling, that'd be like when you'd group freshmen together, you'd group sophomores, juniors, seniors, and you'd take like 10 freshmen, 10 sophomores, and so on. So we can block an experiment, and what that lets us do is it lets us kind of see if there's some sort of pattern. Like maybe sleeping at 10 p.m. is better for younger students than it is for adults. So when we block, we want to group individuals by similar characteristics. So maybe like when I do my experiment for like that sleeping thing, maybe I group older people in one block, and in a different block I would group younger people. All right, so those are 4 principles there of experimental design. Just some vocab here. Statistically significant. You're going to hear this a lot more second semester. And this is when, let's see, when the outcome is too great to be caused by chance, we say it's statistically significant. So like going to that example where we made an experiment and I was saying, is it better to sleep at 8 p.m. or 10 p.m.? And we did 25 people in each of those groups. What if we found that after the experiment, the people that slept at 8 p.m., the results showed that they were more lively, that they had more energy, that they felt better, that their health was better, that all 25 of them performed better than the other group who slept at 10 p.m. If it's like literally all 25, we can say like, okay, that's statistically significant. That's like, there's no way that was just lucky, right? 25 out of 25. That's statistically significant. And as we start getting into next semester, we're actually going to assign values that'll kind of be like your minimum to see if something is statistically significant or not. If that didn't make sense, guys, don't worry too much about that. Control treatments, like I said, this is like the control group. This is well, actually, let's define control group first. This is the group that receives baseline treatment and we can say like typically it's a placebo. Remember, placebo is like a fake treatment. We can call this a null treatment. Null means kind of like nothing. All right, honestly, let's just ignore control treatments for now. So a control group, that's our baseline group. All right, and then just a couple other terms here. Blinding, maybe you've seen this in other courses as well. Blinding is when individuals in the experiment, are not aware of which subjects got which treatments. So blinding, again, we're kind of unaware which subjects got what treatments. So if I took a group of 50 people and we randomly assign them to either you're sleeping at 8 p.m. or you're sleeping at 10 p.m., maybe we don't know who is in what group. That would be a blinding. And blinding helps us. It helps minimize bias. All right. That the reason we want to do blinding is it can minimize bias. And there's two types of blinding here. There's single blind and double blind. So single blind is when either the experimenter or subjects don't know. So, like I said, maybe in the case where we're talking about sleeping at 8 p.m. or 10 p.m., it would be a single blind if the experimenter, so the person who's looking at the results, maybe they have no idea when they're looking at somebody if they slept at 8 p.m. or 10 p.m. Or in certain subjects or in certain experiments, the subjects may not know. That'd be a single blind. A double blind would be not when either, but when both the experimenter or subjects don't know. And the example that I'm using with like sleeping at 8 p.m. or 10 p.m. doesn't really make sense to do a double blind because I think you should be aware of what time you're falling asleep if you're participating in the experiment. But for some other experiments, it makes sense to do double blinds. And we'll see examples of those. So placebo, I guess I really didn't explain that earlier before, but it's just a treatment with no effect, like a fake treatment. So I said, hey guys, take this little magic water and you're going to feel fantastic. All right, I just tricked you guys and I actually just gave you just plain water. That would be like a placebo. But maybe mentally you actually think that you're getting a treatment. So it might actually have an effect on you. All right, guys, we'll go ahead and stop there with these notes.